All right, let's dive right in. We are talking about one of the most ambitious projects humanity has ever taken on, an incredible piece of technology being built to answer that one single question that's been bugging us for, well, forever.
You know the one I'm talking about. Are we alone out here? It's a question that has driven, well, everything, from our oldest stories to our most advanced science. But what if we're on the verge of actually finding an answer?
So say hello to the Extremely Large Telescope, or ELT for short. And let me tell you, this is not just another telescope. This thing is a revolutionary machine, basically a giant, superpowered eye that we're building on top of a mountain, all for one reason, to stare out into the deep dark and hunt for other worlds.
So what makes the ELT such a big deal? Well, it's got this incredible two-part mission. On one hand, it's going to hunt for signs of life on planets around other stars. And on the other hand, it's a time machine. Seriously, it's designed to look so far away, so deep into space, that it can literally watch the dawn of the universe.
And to really get a sense of just how powerful this is, let's compare it to the legendary Hubble Space Telescope. The ELT, it's going to give us images that are 15 times sharper. But get this, its giant mirror will pull in 100 million times more light than your own eye can. I mean, that's not just a step up. That is a whole new level of seeing the universe.
Okay, so you're going to build the most powerful telescope in history. Where do you put it? Well, funny enough, the absolute best place for it turns out to be one of the most hostile, most alien-looking places you can find right here on Earth.
So why there? Why go to all that trouble? Well, for astronomers, the #1 enemy is our own atmosphere. You know, clouds, haze, all that stuff that blurs the view. The Atacama Desert in Chile, it basically solves that. We're talking over 320 perfectly clear nights every year. That's more than 3 times better than what you get in Europe. It is, hands down, the best window to the cosmos on the entire planet.
And when I say extreme, I mean it. This is the driest non-polar desert on Earth. There are places there where it has never rained, ever. It looks so much like another planet that NASA and other space agencies actually test their Mars rovers there. And the best part for a telescope, it's in the middle of nowhere. Absolutely zero light pollution.
But, you know, finding the perfect spot, that was the easy part. Actually building this thing on a remote mountain peak, that wasn't just a construction project. It was a full-on war against nature.
So they picked this mountain, Cerro Armazones. It was perfect, except for one tiny problem. The top was too pointy to build on. So what was the solution? Oh, it was pretty simple and pretty dramatic. They just blew the top off. Yep, they used explosives to shave off the top 100 meters to create a nice flat platform. And to give you an idea of what that looks like, we're talking about 4.7 million cubic meters of rock just gone. That is an insane amount. It's enough to fill over 1,900 Olympic swimming pools. And remember, this was just step one. This was just clearing the site. But, yeah, there was a but. This brute force method created a huge, scary new problem. The explosion fractured the mountain's core. The ground itself became unstable, and these dangerous sinkholes just started popping up everywhere, threatening to literally swallow the whole multi-billion-dollar project. And if that wasn't enough, they also had to deal with earthquakes. This whole area is seismically active. So the engineers came up with this brilliant solution. They built a foundation for the telescope itself completely separate from the big dome building around it. Then they connected the two structures with these enormous hydraulic dampers. Think of them as the world's biggest shock absorbers. So if the ground shakes, the tremors never even reach the super delicate telescope.
Okay, so the foundation is solid. Now we can get to the really cool part, the technology inside the ELT. This is where we answer the big question. How can a telescope on the ground possibly see clearer than one floating in space?
Well, it all starts right here, with the main mirror. This thing is huge. We're talking 39 meters across. That's 128 feet. It's so big, you can't possibly make it from one piece of glass. So instead, it's built from almost 800 smaller hexagonal pieces, all fitted together perfectly to act like one single gigantic eye.
But the real secret sauce, the magic trick, is a technology called adaptive optics. See, even in the super clear air of the Atacama, our atmosphere still messes with starlight, makes it twinkle and blur. Adaptive optics is this incredible system that fixes that blur as it's happening in real time. And that's how the ELT gets a view that's even sharper than Hubble's.
So how in the world does it do that? Okay, this is where things get straight up sci-fi. The telescope shoots these powerful lasers 90 kilometers straight up into the sky. The lasers hit a layer of sodium atoms, stuff that's just floating up there from meteors burning up, and it makes those atoms glow. It literally creates an artificial star in the sky. And that fake star gives the telescope a perfect point of light to measure exactly how the atmosphere is wiggling around.
All right, let's follow the light. It comes into the dome, hits that huge main mirror, and then bounces between a few other mirrors.
But the magic happens at mirror number 4. This one is special. It's flexible, and using the information from that laser guide star, this mirror morphs its shape thousands of times every second, perfectly canceling out the atmospheric blur. Then a 5th mirror stabilizes that crystal clear image and sends it off to the scientists. It's just incredible.
So all of this, blowing up a mountain, fighting sinkholes, shooting lasers into space, it's all for one reason. It's all so we can finally bring those distant, mysterious planets into focus and start looking for other Earths.
And this is the real game changer. See, up until now, we found most exoplanets indirectly. We see a star get a little dimmer when a planet passes in front of it. But the ELT, it'll be the first telescope ever that's powerful enough to take an actual direct photograph of an Earth-like planet circling another star.
And taking a picture is just the start. By breaking down the light from that planet, the ELT can figure out what's in its atmosphere. It's going to be looking for biosignatures, the chemical signs of life, things like water, oxygen, carbon dioxide. It might even be sensitive enough to spot signs of alien pollution, which would be a pretty big giveaway that someone's home.
And then there's that other mission, looking back in time. It's a simple idea, right? Light takes time to get to us, so the farther we look, the further back in time we see. The ELT's giant mirror is going to catch light that's been traveling for 13.5 billion years. That lets us peek 100 million years closer to the Big Bang than we've ever been able to before.
Just think about that. The universe is about 13.8 billion years old. The ELT is going to see what it looked like when it was just a baby, only 300 million years after the Big Bang. We're talking about getting a front row seat to see the first stars and galaxies switching on for the very first time.
The crazy thing is, we don't really know what we're going to find. That's the exciting part. But history shows us that every single time we've built a more powerful eye to look at the sky, it completely changes everything we think we know. Just like Galileo's little telescope did hundreds of years ago, the ELT is probably going to show us a universe we can't even begin to imagine right now.
So the finish line is in sight. It should be ready to go in 2029. After all that work, decades of planning, moving mountains, inventing technology that sounds like magic, humanity's greatest eye will finally open. And it all comes back to that one huge question. Will this be the thing that finally tells us that we are not alone?